Thanks everyone for joining me today on my session. My session is going to cover simple steps to build more secure applications. So who am I? I'm Bryan Davies. I've been doing software development for over 20 years. Along my career, I found a lot of really poorly written code, and I'm actually going to show some examples of that today, and I'm also going to highlight the stuff I've learned. I've also had the opportunity to work on some really cool projects over the years. By far, my most favorite project was doing a vision system for Nortel office phones. Remember the old Meridian phones? Yeah, I worked on some stuff related to them way back when. So that was a pretty fun project. So in today's presentation, what's going on? As I mentioned, I'm only going to introduce some concepts to build more secure applications. The idea is this is stuff you can implement right away. It's also meant to be something that all your developers can understand, not just your senior guys, but it's meant to be also geared towards your junior staff. And so, like who's this for, right? It's for anyone who works on code, your tech leads. The tech leads get asked these types of questions, so I'm hoping to give them the tools that they can answer these questions. And junior devs, if they know some of this stuff, it helps them along in their career path as well, and they start to know what type of questions to ask. So why do we even have to do this talk? This is kind of the one thing I've found in my career is I have to go over the same stuff over and over. We're really good at focusing on infrastructure for security. Software is still playing catch up. Right? A great example of this is web application firewalls. Why do we need them? If we're so good at preventing SQL injection, why do we need these firewalls that check every single request that goes into an application, right? And that's what we end up doing is we end up preventing attacks and stuff via infrastructure, mainly because a lot of our software just has these security holes. So I'm going to try to show stuff to help plug some of those security holes, right? And still to this day, you'll go to a website and you'll see like a client ID in the URL. Like how often do you guys try to change those? Right? I do. I muck with those. See what happens. And you shouldn't be able to change a client ID from 1 to 2 and get a different person, but you still do. We also run into the problem of legacy applications, right? A lot of them, people just are afraid to change stuff. There's bad SQL stored procedures buried somewhere in those systems. And so there's just problems with those. I'm also going to show you some stuff on how to fix that. All right. So I'm going to jump into it here. I'm going to start off with maintainability. And this is my opinion, but this is something, again, I've seen over the year. In my opinion, maintainability is the most important security feature. And it's because if your code can't be maintained, it can't be fixed, right? If there's some sort of login bug, yet no one understands how your login code works, you can't fix it. So maintainability is really, really key, right? There's also stuff changes all the time. All of a sudden, a certain, crypto technology might get cracked. So now you have to change it in your application. Well, if your code isn't maintainable, you can't change it, and therefore you're kind of left behind, and now you have a website or a web application that has a known hole in it because of the cryptology technology you're using. So it's really important to have code that's maintainable. You can move it forward because of that. So the stuff around maintainability, all the acronyms, right? You hear those all the time. Those are around like job, what are they called? Like the job boards, you see them everywhere. You guys know to use source control, build servers, testable design. You know this stuff. So this is the boring stuff. That's why I got the sleepy little panda there. It's the boring stuff. So stuff I want to go over though, code intent. This is really, really important. This is one of the most important things about code maintainability. Now, your dev teams are going to claim, well, code is self-documenting. And yeah, it is. You can kind of rip apart code to figure out what's going on. The problem is if the code has a bug, then the self-documentation has a bug. And essentially the intent is lost. And that's really key, right? If there's a problem in the code, if you look at it, well, how do you know it's a problem? Or is the code doing exactly what it's supposed to, right? You don't know, because if the intent is lost, you can't make that determination. So code intent needs to be clear, and make use of the header comments, right? Make use of inline comments, name the class accordingly, name the functions accordingly, name the variables accordingly, and then don't be afraid to change stuff too, right? If the names are wrong, change the names. And always kind of remember what it's like to fix someone else's code, right? All the time you spent cursing them, make sure you're not writing code that ends up with someone else cursing you, right? Fix those things. Try to include the intent on the code. write smaller functions. This is one, people are getting better at this, so but I do want to throw it in here because it is still stuff that you come across where I've fixed code where I essentially had to print out the function and it would be 10 pages long printed, and I had to like draw the loops on the printed out paper and basically try to figure these things out. That is a massive pain. And so if you can write smaller functions, it's easier to maintain, it's easier to fix, and you know, it just makes everyone's life easier. No one wants to be scrolling all over when debugging, so make these things smaller. If you have a smaller function, they're easier to replace, they're easier to refactor, they're easier to kind of change, right? They're easier to understand, and it's really easy to show the intent, right? You can have a function that basically the name is, you know, save data, and there's 3 lines of code where it saves the data. Well, that's pretty easy. It tells you what it's doing, it does it, and you're done, right? So smaller functions really help with maintainability of code. Levels of abstraction is an interesting one. So by this, I mean not just levels of inheritance, I also kind of mean the call stack, like depth of function calls. And what I've seen is I've worked with some developers that can easily hold 5 levels of abstraction in their mind while they're debugging, right? Or while they're troubleshooting something. Most can't. Most are 3, and that's it. And so what ends up happening is if your levels of abstraction are more than 3, or if your call stack gets way more than 3 classes deep, people get lost and they can't figure out really what's going on, and everything gets harder. So all of a sudden the maintainability of the app is harder. Troubleshooting something to find a problem is harder. Just understanding the structure of the code is harder. Everything gets harder. So I try to teach my devs to have a rule of thumb of don't go more than 3, right? Whether that's, again, the call stack depth or whether that's an inheritance depth, it seems to work for both cases. Now, there's going to be the odd time you do need more, and that's fine, but you know, don't make a habit of going over it. And the other thing that you'll find is quite often if you're going over it, it actually might be a sign of bad design, right? Like if you have a function that's a controller class that's doing a save method and it calls into the business layer to do save, and then that business layer takes basically a whole bunch of models and saves each one by one, that's not that hard to follow through, right? It's 3 levels deep. It's pretty easy to understand. But if each one of those individual save calls another save for some other variable or for something else, and it starts to daisy chain down, then all of a sudden that becomes really confusing for people to figure out and stuff. So try to stick to 3 levels. Naming is super hard for stuff, but dev groups, you guys have to figure this out. It's hard work to name stuff, it really is, but don't be afraid to rename stuff. That's one thing I tend to see over and over. You'll end up with a terrible name for a function and no one will change it. They'll just live with this bad name. And I mean, there's tools to help with this. There's refactoring tools. Visual Studio has refactoring built in. There's RESHARPER. There's tons of tools that help you do safe name changes. So make use of them, right? And don't be afraid to change. In fact, you should change the name if the intent changes. So for example, if you, again, going back to my save example, if you have some sort of save data and now it's not saving data, it's now just doing a safe check for saving data, some sort of pre-check, rename it. Don't keep it called save data because now the intent is lost, right? So naming stuff, we know it's hard, but you know, work on it anyways, and don't be afraid to rename stuff. It's more the renaming that is the thing I want to focus on because you don't see that enough. People don't correct it. Avoid clever code. This drives me nuts. There's way too many developers that try to be clever and they have a single function that's doing about 50 different things and no one else can understand it. Clever code loses meaning, it loses intent, and it's impossible to maintain. So just avoid it, right? It's just write simple code. It doesn't matter if there's going to be more objects, more variables, more calls, right? You can always go back and do performance checks on it later and clean it up later, make it a little bit better performant. But if you're initially writing it clever just for performance reasons, that's actually a really bad practice. And like I said, no one can maintain clever code. So what ends up happening with clever code is it ends up getting deleted after someone spends way too much time fighting with it, trying to figure out. Then it just gets removed anyways. So best is just to avoid it. There might be exceptions, but it's really doubtful that your code is one of the exceptions. So, you know, it's just best to avoid clever code. Right, I'm going to talk about authentication and authorization now. And again, the stuff you know, again, the Sleepy Panda. You know, store your passwords as hashes and salts. Don't write your own encryption, right? And developers know this stuff, right? You sometimes think about using a GUID for a user ID. Don't always, but at least you think about it. And you kind of know that rule of not using user ID 1 for the power admin, right? How often do you see that in old sites where the ID 1 is the super duper admin? So it makes it a little easier to trick. So I can't stress this enough. Quit writing your own authentication. Quit writing your own authorization. Just quit it. There's trusted third-party libraries. These libraries are included in frameworks like .NET has its own authentication. I know Java has one. Like, these are already baked in. Make use of them, right? There's other options too. Start simple and expand, right? The whole goal of, again, the maintainability of code. It allows you to start with one of these frameworks, use a little bit of it, and then if you need more, you can swap that piece out for another piece. Again, if your code's maintainable, you can do that sort of stuff. So it's really important to quit writing your own. And I really mean it. Quit writing your own authentication and authorization. I've seen way too many problems with this. Leaky multi-tenant apps, right, where you can change the user ID right in the URL, right? I've seen backdoors. I've removed this backdoor that I mentioned here where they had a check if the machine name started with dev, right? The code for developer. But guess what? We were selling oil and gas software, and the target client at the time was Devon Energy. All their machines started with dev. So you have these backdoors that might have unintended consequences, right? So you have to be wary of that. And if you are writing your own, it's easier for developers to sneak these kind of backdoors in. So database mistakes. The plain text is still common. People hate writing encryption, decryption code, so they end up just not doing it. Whereas if you use these frameworks, it's kind of baked in, so you don't have to worry about it, right? Integer-based IDs, that one's not too terrible. The reason I include that is because it's really common to use those types of IDs in URLs, and so that's why I'm making that. Whereas if you use a GUID, you can still throw it in the URL, but they're a lot harder to guess a valid one for. So that's kind of why I throw the integer-based IDs. And I have an example later of where some code I came across where char fields were used in username and passwords. And I'll explain more as to why that's a bad idea. The other thing I find with login code is it's written once and never touched. The guy who wrote it never ever tidies it up, never goes back to fix it. It's just written. So the idea is like these abandoned GitHub projects have more updates than login code that's in your main application, right? So it's dangerous to write this code once and then never look at it again. Whereas if you're using these frameworks, they're updated all the time. If there's something's been cracked, they update it and remove that piece from the framework. So that's another reason why to use these frameworks. And if you're writing any sort of software that's going to be used by a public company, there's a chance you could get audited. You'll fail the audits with your own hand-bombed login code. So just quit doing it. It's just a bad practice all around. And I still see it way too much. So another thing I see way too much is the authentication, or sorry, not the authorization. So you're not authorized to do something, so they hide the buttons. Oh, the buttons are hidden. They can't do anything. Well, what about F12, right? Who doesn't use F12 to kind of unhide buttons or, you know, remove like a grayed over thing on a website, right? That's super common. So it's just too easy to do that. Or a fiddler, you can actually use tools like that to create your own post request. And then actually, so the button's hidden, doesn't matter. I can still send the request to the website. So hiding buttons, it's not enough. So you have to do more, right? Hiding a button does not stop the request. So you have to start checking for authorization and authentication on the function call. Right? Get in that habit of checking on that stuff in the function call. All right, so I found this code long ago, and so I have to show it. It's basically the worst authentication stored procedure I've ever come across. This actually was protecting approval system for financial projects worth around $5 million. So I'll kind of jump into the code here a little bit. It starts off with there's like searches using wildcards. So like username with wrapped with wildcards, like password. That allowed me to actually log into the system using the letter E for both the username and the password. And I'm going to hint that SQL injection in this. If you look a little closely, you'll see that this is actually susceptible. And I'll come back to that in a bit. But yeah, the fact I could log in with the letter E and letter E. It's kind of crazy. If you looked a bit more, you could tell that this was essentially bad code reuse. the stored procedure was not designed for authentication. It was actually designed for administration. You can see there's a if username is blank or is not blank, right? And then it jumps in and does this. If it is blank, it would jump to the bottom and just return all the users. So the idea was this was actually meant to fill a user administration grid. And I did dig into it a bit more, and sure enough, in the app, there was a user administration grid that was making use of this code. So that's kind of bad code reuse. They're trying to use the same stored proc for two different purposes. Digging into it a bit further, there was also a bad database design. So you'll remember there was like searches and all that stuff. Well, even if they wrote their own very specific login code, they'd still end up using a like search, and that's because the database uses nchars. So for those who don't know what nchar is, or char field are the same, basically, but they're padded with spaces. So if you don't use the full 100 characters, like this one's saying it's going to be 100 characters long, then it fills it with spaces at the end, okay? And so if you have a like search for your login and a like search for your password because you have this database design that has padded spaces in it, you can actually log into that system using space and space. The interesting thing is when you do something like that, you get the table returned just in the order of the data being in the database as how SQL wants to store it. And that typically means your admin user, which is the first record, comes back first. So you end up kind of being able to log in as admin using space and space. I mean, there's a lot wrong with this. It's using IDs as integers. There's also no encryption was on this. It was just bad all around. This one was. So I kind of want to point that out. And the reason I want to really point out the database design is because quite often developers inherit a database design and you're stuck working around it. And quite often developers are afraid to change a database design. But if you see stuff like this, like a char field with 100 and storing you know, your username, password, you have to fix this. It's probably a low impact. You're probably just going to end up, there's probably trim statements all throughout the code to kind of manage this, and you'll just essentially make them not required anymore. But it's really important to kind of fix this stuff, and don't be afraid to snoop at the database. That's the other thing I see, and I'll get into that a little bit, where developers are afraid to go past the data layer. So that actually brings me to SQL injection. Okay, and so the stuff, you know, that's a classic injection string at the top. You know, the SQL injection via the URL. Some people have used URL parameters, and they actually just use it verbatim in a SQL call. That practice, thankfully, seems to be going away, which is good because that was a really easy way to perform SQL injection on websites. Everyone's taught parameters are safe, concatenation is bad. You know, you sanitize your inputs, and I don't know, most people I know curse using regexes, but you're kind of stuck using them for that sort of stuff. I want you guys to learn your ORMs. They're black magic to most developers, but it's important that dev teams understand how they work. ORMs hide a lot of stuff, and it may be hiding the fact that there's some SQL statements behind the scenes that are being used that are actually susceptible to SQL injection, and you might not know it. Right? You look at the ORM, and that's the other thing. People are told, oh, if you use an ORM, you're not susceptible to these problems. But you actually can be. It depends on the database design. It depends on the ORM design. It depends on the business object design of the ORM. And I'll show you an example of this where an ORM was in front of business objects, or sorry, SQL objects, but it was still susceptible to SQL injection. Added bonus, if you learn how your ORM works, it can help with performance improvement. Like a good example is Entity Framework and ToList. If you look at any kind of ORM stuff, people call ToList way too often, and those are expensive hits to the database. But again, that's a different talk. We'll kind of keep going on this ORM stuff here. Next is the data layer. Dev groups need to learn your data layer. Again, that seems to be kind of, quite often you inherit it and it's kind of black magic. You don't really know what's going on. You're told to use parameters. It's really important when you're doing any kind of data layer stuff to also use parameter value types and value size. Database servers will make assumptions if you don't do that. And if they make assumptions, you can trick them. And I'll actually show you some of that where I trick a data layer to assume values I want it to assume. And then, of course, you want to use the param name in the query string exactly. And again, I'll show an example of that because that it can be kind of meaningless to a junior dev just reading that statement. It's really important to not use SQL parameters in string concatenation. It kind of basically defeats the purpose. And this stuff's important, so you have to try to review it with your junior devs. Books don't really do a good job going over this. In fact, quite often examples in books are incorrect. They're just trying to show you how to get the concept across, so they kind of show you bad habits. All right, and it's not just logins. Over the years, I've seen logins are getting better and better at being protected. People are using the right third-party frameworks, and so they're actually getting more locked down. However, search pages are also very susceptible to SQL injection, and I'm actually going to show you some stuff here on the side. What you can see is what I'm doing on the side here. I'll actually get the mouse to show up. Okay, so essentially, the top part here, what I'm doing is I'm just trying to figure out the width of a search. So the idea is I have a search bar where I can just type stuff in and I get a grid of results back, okay? So I want my first bit of text to be some sort of fake search that brings no results back. I want to make sure it brings back nothing. And then I union that with a select statement showing a bunch of quotes and ones. The reason I do that is, again, remember, if my parameters aren't explicitly saying what value type that is, I can make SQL assume that a one in quote is text. It'll assume it's almost any numeric value, and it can also assume it's a date. So I can do that in there to kind of bypass any sort of value type checking, essentially. And all I'm doing is trying to figure out the width of the query, because of course queries tend to have columns that don't show up in the grid and they're hidden, like IDs and stuff. So I'm basically doing this until I get no errors, right? And now I kind of know by using this union query that I'm injecting into a search string, I kind of figure out the width of my grid, my search results. And now I can do stuff like this, where I can include a search for the table names. And I mean, you don't just have to do sys tables, you can do the information schema. And the reason this tends to work is because most applications have database owner. So I can see anything in the database. And so I might not have the sys table. I believe you need sysadmin to run, but you should still be able to get the list of the tables if you use the information schema if you're database owner. So now I got a list of the tables, right? And then I can do the same sort of query below to get the names of the columns within that table. And so the idea is, people aren't always after login information. Maybe I'm after credit card information in this database, right? Maybe it's something like a Home Depot site where you don't even have to log in, but I know somewhere behind the scenes there's going to be credit card information. So I can use their general search to find stuff, and you can do these types of techniques to find it. So it's really important to lock down your search, right? It's not just the login page, right? And so I just wanted to show you this. There's a few little mistakes in this, so it actually won't run as it is, but this is essentially all you do. And I've done this type of stuff on in-house apps before to teach dev teams how you can attack this stuff and why it's important to protect against it. Because a common thing is, well, they can't get the login page, we're fine, right? But you have to protect any kind of area where data is being input. Okay. So injectable parameters, I mentioned this before. Common thinking is it's a parameter. It can't be injected, but that's wrong. And again, this tends to be something you see more in inherited old applications, where this top on the begin where it says bad way, this is a stored procedure, and this is a string concatenation style stored procedure. This style of stored procedure was really common even like 10 years ago, like super common. And that's susceptible to SQL injection, right? You're using parameters, but if it puts that parameter in there, it just is going to put it in as text. So now all of a sudden it can be injectable. And so you want to use the way I'm showing below, where you're actually using them as variable types, and the SQL is written out as SQL, not an execute and then string concatenation. So the trick with this, that top stored proc, that's a real stored proc I pulled out of an application I fixed. And they actually they didn't use an ORM, but they did have some business logic and some data layers that called this. So if you looked strictly at the business layer, it looked like it was doing everything fine. It was using parameters, it was passing it in, the parameters were included on the stored procedure. Perfect, it looked totally fine. Yet it was injectable, and that's because when we were digging at it, no one thought to look at the SQL side. No one looked past the ORM. And that's another common problem. And that's why I mentioned it's good to learn the data layer, good to learn the ORM, because then you know to look past it. If you see something and it's injectable, you don't just see, oh, there's an ORM, we're fine, or oh, parameters, we're fine. You actually will investigate a bit further, and you might find these types of things. And a really easy way to find these sort of stored procedures is most SQL servers or database servers, you can script like a build script that builds all the your database, all the items in your database. So if you generate one of those, you can literally then in a text editor just search for 3 single quotes and see how many stored procs have those 3 single quotes, and then you can actually find a lot of stored procedures that might have this problem, right? And that's what we did where I was working before. We actually basically dumped all this to text. We did a few searches, we found them all, and then we started to fix them. Right, and again, it was all kind of hidden behind a data layer, so no one even knew we had these injectable stored procedures, and so we started digging in. All right, internal frameworks. So this is internal frameworks are the items your dev team builds for your own dev team, right? And so you'll have tons of these, right? Everyone has tons of these. So again, the stuff you build it, you fix it. You hate fixing other people's stuff. That's why you kind of have these internal frameworks. There's some really good books on it. Framework Design Guidelines is a great book. It's more .NET focused, but it's still a really, really good book. Patterns of Enterprise Application Architecture, that's a Martin Fowler book. That's another really good one for kind of figuring this stuff out. I highly recommend both those books. When you're building your frameworks, you have to design with security in mind. Now, you always hear this, right? You always hear this talking to any kind of dev or person, but what does it mean? And what it means is you need to plan your security, right? You need to authenticate at access points, you need to authorize at calls and requests, and you need to encrypt your data. So I made this little graphic here to kind of help explain that, right? So authentication, that's is this user allowed in the application? That's what authentication is, right? Are you even allowed in? And so you want to do that, your sessions, your tokens, your cookies, your login page, anything that's kind of impact those, you want to check for authentication. Authorization is more, you're allowed in the application, but are you allowed to do this? That's your user roles, right? Are you allowed to save? Are you allowed to bring back that data? And you want to do authorization checks at your controllers, typically your models, right? That's more if they're allowed to see the data, and obviously your function calls. And then the encryption, that's a little bit self-explanatory, right? Your transport, your database backups, or you're encrypting at rest and all that. But you need to kind of at least have a bit of a plan. Right, and some applications won't need all this. Maybe you just need authentication. You don't need authorization because it's really simple. Or maybe you don't need authentication at all, but you might need authorization. So anyways, you just kind of plan accordingly, but it's really useful to kind of know the difference and know the various things and plan accordingly. And it's also very helpful to have rules. And by that, I mean, if your dev team knows your authentication rules or your security rules, it really helps. So for your frameworks, for example, if I know that this is a controller UI framework, but we have a rule, the second rule down is that all function calls have to have an authorization check if it's triggered by the UI. It's like, okay, that makes sense. Then my little UI focused framework, I'll have to have authorization checks in, right? Or if you're writing the data layer and your rule is all functions that save or retrieve data have to have an authorization check. Okay, perfect. I'm writing that layer. I'll make sure I put those authorization checks in that layer. So if you have an idea of these rules that coincide with that previous drawing, then you can kind of come up with a plan, and it allows the devs to get a really good understanding of the plan, because otherwise there's just a lot of hand waving and talking about this stuff and no one really understands what's going on. So it's really, really important to kind of have it planned out. Then there's less problems in the future. All right, the other thing I try to encourage devs to do is push their security lower. And by that, I mean, if you think of your application as like the layer cake design, if your security stuff is at a lower layer, then more stuff is forced to go through the security and you only have to write it once. Okay, and so it makes it a little less error prone. You don't tend to forget things, and it also forces a little bit some interesting practices. And I tried to write some code for this to give you the example, but it was a bit too tricky. So instead, I just kind of have a written out example at the bottom, and I'll just kind of walk you through it. So at one place I worked, what we did was what we had is a multi-tenant application, and we needed company ID and everything. So originally, it was the developers had to remember to include where company ID equals active company in all their queries. That's error prone, right? You have a developer who's, you know, tired one day or whatever, about to go on vacation, so his mind's not right there. Very easy to forget that in a query. Very, very, very easy. And then you have a leaky multi-tenant application totally by mistake, right? It's not, you weren't hacked, it's just someone forgot the where clause. And so what we did was, on the database repository, we added company ID as a property. And so whenever you use the database repository, by default, it grabbed the company ID from the user object. So there was nothing that the developers had to remember, because part of the query was you sent the user ID anyways as part of the object in the repository. So it already had the company ID. And then the other thing we did on the repository to help enforce our rules, the repository would error out if the company ID was blank, null, or like a special case. Like, for example, sometimes people try to send -1, meaning return everything. Well, we didn't accept that. If that company ID didn't match a company in the database, it would error out. And that was by design. And that was so there was no possible way that the repository would allow you to get data back for all companies or for the wrong company. And so we do stuff like that by pushing it lower. Now, all of a sudden, that's completely out of the developer's hands. The chance of a mistake is greatly reduced, right? So that's a really important way to handle some of this security. All right, modifiers. Okay, this is the stuff, you know, the private, public. You know, I don't know about you guys, but myself, I have to look up everything else in between. I can never remember. And they're slightly different between languages anyway, so it's useful to look them up. All right. So I've seen so many mistakes with modifiers, especially with, this is a common mistake with junior developers. And I don't mean to pick on junior developers, but it's easy to make everything public. And dev teams, please stop doing that. There's so many reasons as to why you shouldn't. And you start with private and then elevate as required. There's code analyzing tools that help with this. They'll actually say, you know, maybe this should be public, or maybe this should be protected internal, or whatever. They'll tell you which type of modifier to use. And they'll also tell you when you should potentially restrict access. And so RESHARPER has some great capability, and Visual Studio Code Analyzer has some stuff baked in it as well. It's actually really important because it's really easy to make mistakes with these modifiers. And so here's just a list of some of the ones that are in between, right? From private, there's protected private, internal, protected internal, public, and then even static, which is kind of a special case. But so there's lots of choices. It's not just private or public. There's lots of choices in between. It is worth knowing the difference, mainly because it allows you to enforce a good design. And did I skip a slide? No, okay. So I'm going to show you a simple bug, and it's all because of code modifiers being incorrectly used. So the top part's the controller code. I'm showing both potential calls, right, where they hit a save button, and the intended use is they should call save data safely. However, you can also call this save data, and that's the one that they accidentally called, right? And if you look at the business logic below, the save data safely has a check for save permission. So it's just verifying that the user has the correct permissions. If they do, it's going to call save data. This is a pretty standard style design, right? Where it's just does a permission check wrap around a simple save that's more meant to be private. Now you'll see the save data, which just calls the save stuff, it's public, right? And in reality, in this case, it should be private by the way it's designed, right? So that way the controller code should only be able to call save data safely. It should not be able to call save data. But because that was accidentally made public, it can call it. Now, this type of bug is hard to find because there's no error, there's no nothing. If you step through the code, it reads like it's doing what it's supposed to, right? Oh, save button. Okay, I click the save button. Let's see, save data. Yeah, saves data. It goes to the save data call. Yeah, saves the data. All right. That's kind of tricky. I don't really know what's going on. Then you might come across, oh, wait a second, the save data doesn't have a permission check. So then here's the gotcha and why code intent is important. There's no comments on save data. There's no header information. There's no information. Just says database that calls to save the data. Well, that's no different than having save data as its a method name. So because the intent is lost, it would be really easy for someone to fix this by writing a permission check inside the save data function. When in reality, the proper fix is making the save data function private. Because you write that permission check, then all of a sudden what you're doing, it's still going to work. But basically, all the other places where save data safely is being called, you're going to basically do the permission check twice. So you've kind of doubled up hits to the database and stuff. So again, this is kind of why the intent is important, right? Because in some cases like this, you go to fix it, you fix it wrong, essentially. And that might have accidental consequences. In this scenario, there's not really much for accidental consequences, maybe some performance hits, but there is the potential for problems because the intent is lost. And again, the other thing I want to point out with the top in the save button click, the intended use, save data safely. If you were starting to type save data, IntelliSense on your Visual Studio would pick save data, the simple one, the incorrect one first, because it's alphabetical. So that would show up first. Developer would see it. It would see it's public. Good. They'd hit tab. They'd move on. Right. So it's another reason why having the modifiers in place actually prevents incorrect use of your code. Right. So it's very important to have that. All right. Process changes. So this is like dev process stuff. So I'll get into that. So again, the stuff, you know all the acronyms, source control, build server. I hope you're all using source control. I have come across that recently still where companies are not using source control. So please do. Testable design, integration test. People are already using this. They know this stuff. Really good books on that. Code Complete. That's like a classic now, which is hard to believe. Anything by Martin Fowler tends to be really good, and Pragmatic Programmer, of course. So most of the devs out there will be familiar with those. They're great books for this stuff. But here's something. Always admin. This is a bit controversial. Your devs need to be local admin. Let them have it. Right? This is a common sticky point with IT groups, especially if they're not a company that's a 100% software development shop. Those companies tend to be a little bit more relaxed on this. If they're another type of company with a dev team internally, this is a sticky point. But your dev team needs it. You can't debug, you can't do stuff, you can't do half your work without local admin, right? So instead, plan for it, right? Accept that it's going to happen, plan for it, design for it. And by that, I mean, if for whatever reason, if the application you work on requires a tool like Wireshark, right? Wireshark's a packet sniffer, allows you to snoop on everything on the network. Well, then design so that the dev team that needs that system or needs those tools is on a separate network. Have firewalls in place to make sure they're not accidentally snooping on stuff in the company that they're not supposed to. But you need to plan for it. And all too often what I've seen is just, no, don't use the tool. No, you can't have admin. And then it just causes problems. The other thing is devs will find a way, right? I've even been one of these early in my career where it's like, you need a tool, you can't get it in. Well, you bring it from home, you bring it on a USB stick, or in some cases, you'll convert it to some sort of file format, or you'll encrypt it and change it and email it in or whatever, right? There's always a way to get these files in. So it's better to plan for them having admin and accept it and protect accordingly versus making them be sneaky and bring in stuff that you don't want in your network. So just, like I said, it's kind of a controversial issue for some companies. So hopefully this is something that can change. The other side of this is if you're going to have admin access on your dev environment, you have to handcuff test in UAT. They have to use the lowest permission possible, right? No, even your integration tests, use simple read-only, use standard user, do not use your God mode user. And you need to do that for testing. You have to verify that everything's going to work. And you don't want to find out when you're pushing to production that you need elevated access, right? And typically elevated access is a problem of bad design, or the problem's misunderstood, or something else. So make sure you're testing in UAT by having the permissions really reduced, like as reduced as possible, okay? And that goes for the database too. Way too often, the database account that the application uses is a very elevated account. Like, I mean, it'll be database owner, it'll be, in some, quite often you still see it's database admin, and you don't want that. So you want to use basically DB read, DB write. You want to kind of restrict that access. And then in your testing environment, try to break your logins, right? Have integration tests that try SQL injection. Have integration tests that try space, null. Try to overflow it. Have tests that don't even use the login page, but instead have posts that hit the service directly or whatever, right? Because that way you're actually testing it, not just testing the UI validation. So you actually want to hammer the UI, you want to hammer the login page on your testing. Try to break it. This is what's in your repo. Repositories quite often have plain text in the source control, plain text passwords, connection strings that have username, passwords, private encryption keys, all that good stuff. Typically, it's fine. Typically, a lot of people tend to have access to your code repository, so maybe you don't want to store them there. And there's also been a big push lately where a lot of code's being made open source or put on public facing code repositories so that external people can see and use it. So if you're going to do that, you might want to just snoop through your code for plain text passwords, other kind of information that can be used against you, right? Like you don't want your private keys out there on a public repository. All right, third-party libraries, stuff you're going to need third-party libraries. Just have a process to review them and enforce it, right? That's really important. So devs love free libraries, right? But you have to be careful. Are you sure you need it? For one, who made it? Did you check that it's secure? And by that, I mean, like what I've done in the past is when you're using the library, is it calling home, right? Like is Wireshark detecting any funny stuff that the library is doing? Is your firewall popping up little things saying, hey, do you allow access? Do you want to allow this? Because quite often there's a reason it's free. Right? Not every person out there is, just coding for the sake of coding, right? So sometimes there's some shady stuff out there. So be wary of that sort of stuff. Don't just pick any free library. In many cases, it's better to spend the cash, right? A well-built library is worth the money. It's maintained. If there's a security problem with it, they'll fix it. It's worth it. It's really worth it. And the problem I've always come across is devs love the free tools. I don't know why, but they just love them. Whereas the product managers and security teams, they like the really expensive tools. But so find somewhere in the middle. There's probably some cases where you want to spend the money, and maybe there's some free ones that are just fine. But just have a review process, and don't just let the devs put anything in the site. That's very problematic. And also make sure your local libraries are installed local, right? You don't want a website where half your libraries, your JavaScript libraries, are installed on the provider's website, right? Or you don't want libraries that need to call home. Like why is it calling home? Why is it loading some additional files from a different server? What's going on there, right? And so there's a couple of reasons for that. One is, of course, it prevents unwanted changes. The provider of the library isn't changing stuff that then breaks your site. But it also prevents manipulation of your application. And a great example of that is if you check out Troy Hunt's write-up on the COINHIVE. That I'm not going to get into today, but just Google Troy Hunt COINHIVE. It's an amazing example of basically a crypto mining JavaScript library that was embedded in a ton of free libraries. So a ton of websites around the world have this in still to this day, and they have no idea it's in there. So it's a really good article to check out. All right, I went over a bunch of useful tools today. So I'm just going to touch on them in here. Just sometimes people don't know the names of stuff. So I'm sure you've heard of JetBrains, Microsoft, Atlassian, but I just did this quick little grid. So for anyone, especially the junior devs, if you heard me say something but you don't know what it is, here's a quick little list just so you can see some of the stuff. I've used most of these tools that are in here, and they're great. They're make your life way easier. So here's, again, I just threw some of this. This is more for the junior devs, so they can kind of see where some of this stuff comes from. Wireshark's a packet sniffer. Fiddler allows you to muck with web programming and build your own requests and stuff. And .trace and .mem from JetBrains are great profiling tools. I've used them quite a bit too. And speaking of JetBrains, ReSharper is a great tool for junior devs. I know like Visual Studio has some code analyzing built into it now, and it's getting a lot better. But I highly recommend ReSharper for junior guys. It highlights problems with the code. It kind of teaches you to be a better developer. And there's some other tools for from JetBrains too that work with Java also for that. And with that, that's the end. We're kind of have a few minutes left for questions. So I'm just going to get out of this shared screen mode so I can see the questions on the chat window. So anyway, thanks for my talk. Again, my name was Bryan Davies, and if you do have any questions after this, feel free to email me. It's just brian.davies@consultant.com, and I'll be more than willing to try to answer. And so I'm just going to check out the chat here. Oh my goodness, a bunch of stuff. And so I'm going to try to start at the top here. Wouldn't more functions mean more levels of abstraction? I'm talking depths of function. So, and by I'm not talking more functions. That's not more levels of abstraction. I'm talking about when you have a function that calls a function that calls a function that calls a function, and it never walks back out of the stack. That gets really, really confusing. More functions is just more functions. Just make sure you design them so they don't have to be embedded 50 deep to be called. That's what I mean by levels of abstraction from a function perspective. Your favorite tool for static. So what would be your favorite tool for static code evaluation and stuff like this? I tend to rely on ReSharper, actually. ReSharper does a lot of just highlight stuff as you're typing. They would call it like the gutter tool. So I really rely on ReSharper for that sort of stuff. And then someone underneath comments, the tools can be language dependent. Yeah, they definitely are. The stuff from JetBrains, which I use, JetBrains also has tools for Python, JavaScript, Java. They even have a new IDE called Rider that supports all types of languages and kind of has the ReSharper tool set baked into it. So I've been happy with their stuff to the point where I haven't investigated much else. So I apologize, I can't really comment on other tools. So there's a bunch of comments on that. So yeah, there's a bunch of comments too in the chat about other checks, which is nice to see. Someone's mentioning something called Brakeman for Ruby, so that's good. And sorry, my screen just refreshed here. Is the presentation going to be made available? I was going to share the presentation with the organizers. I don't know how they're going to share it out. That'd be a question for them, but I was going to make it available for them. Because I mean, to be fair, I think this is something that if you're a tech lead in your group, feel free to share this with your junior guys. I mean, guaranteed you've already reviewed half this stuff with them in some way, shape, or form already, right? But then you get a new junior guy or you get a new intern, you got to go over it again. So it's kind of nice to have it as a little package, if you will. So, all right. Okay, I'm just going to hit the Q&A because I think there's some questions in there too. Oh, that's the same one about the functions. And everyone's talking about Vi. Vi is my IDE. I haven't used that one since having the code in Unix way back when for school. That's a long time ago for me. Any good tools recommended for C# stack analysis? That's still, I kind of rely on the ReSharper. And it's the one thing about ReSharper is it's not so much you click a button and here's a report. You have to kind of be in the code to see it, and I don't really have anything where I've got an analysis with a report. I've always just kind of unfortunately done it while I'm in the IDE and kind of see it as I go, and so I'm not familiar with a tool for that. I'm sure there is one, but I just don't know one off the top of my head. So. And yeah, and there's a bunch of comments saying great presentation, so thank you. I'm really happy that you guys enjoyed it. I really hope you learned at least something from it. I really do. And yeah, someone's commenting on the Devon Energy, and that's legit. That's not a made-up thing. That was the sales guys are telling us, hey, we sold Devon Energy, and it's like they did a test install and they had super access, and it's like, what's going on? So we had to dig into that one a bit, and it's like, oh, someone wrote a bypass. But yeah, so I've come across some crazy stuff, and I'm sure many of you probably have as well, right? So, any other questions? I don't see anything else popping up on chat. But again, my name is Bryan Davies, and I'll throw my email in the chat. Because like I said, if you have any follow-up questions, feel free to reach out. Happy to help. And I've done this type of stuff so much for my internal teams and stuff. It means a lot to be able to get a chance to speak at B-Sides. And thanks to all the organizers and thanks to everyone attending today. That means a lot to me. So.